Hi everyone, it's Learn with Ceri, and I've got some more solutions, tips and tricks for you for Band 1 Quest 3 here. I hope you enjoyed this week's quest. There are some lovely questions to give your brains a workout. In this video, I'm going to give some example solutions for questions 2, 7 and 10. Let's go! Here's an area question. Were you more or less efficient than me with how you solved it? We've got to work out the area of the rectilinear shape below, and so what I did was I started by surrounding it by a complete rectangle. Then I'm going to work out that area and subtract these areas that we don't need. So my first step is to have a quick look at the horizontal lengths. So we've got a 4 and a 6 there. Total horizontal length is 10. And going across here, let's fill in these gaps here. Let's have 2, 3, 3, so that's 8. So this length there is a 2 as well. And let's look at the vertical distances. So we've got a 2 and a 5, so the total vertical height is 7. So this one here must be a 4 because we've got a 3 and a 4 to also make 7. We've filled in all the gaps. So the main area around the outside is a 10 across by 7 verticals, that's an area of 70, and my other area is a 2 by 6, that's a 12, 2 by 4, that's an 8, 12 and 8 is 20, and this little bit here is a 4, so we've got a final answer of 70 minus those bits which add up to 24, so that gives us 70 minus 20 minus 4 gives us 46, and there you go, just a quick one there. Hopefully you got that 46 as well. Lovely. So let's have a look at a fractions question. We've got to let m over n be a fraction such that m over n is equal to 1 over a plus 1 over b. And a and b are distinct whole numbers greater than or equal to 2, so they're not the same as each other. And what is the smallest possible value of m plus n? Right. So my approach to this one is to sort of think backwards really, and I would ideally like m plus n to be 1 plus 2. Is that even possible though? Can we get a half 1 over 2? Can we add 2 unit fractions to get the answer of a half? Okay, not sure, but so half. Think of half a pizza there. What's the next size down in a unit fraction from a half? That would be a third, would be a piece as close as we can get to a half with a unit fraction. What do we need to add to a third to get a half? So let's subtract a third from a half. So I quite like to do a quick 2 by 3 is 6, 1 times 3 is 3, minus 1 times 2 is 2. Oh, that's good, because we've got 1/6. So actually a third plus a sixth actually gives you 3/6, which is a half. So it is possible, and so a half is a possible value. So the smallest possible value of m plus n is 1 plus 2, which is 3. Let's have a look at question 10. Tricky one, this one. A circle with area 72 pi intersects a square with an area of 144. If the circle passes through 2 midpoints of the square and exactly 1 vertex of the square is inside the circle, then the area of the figure formed by the union of the circle and the square can be expressed as a pi plus b root c plus d, where a, b, c and d are positive integers and c is not divisible by the square of any prime. So then we need to find a plus b plus c plus d. Okay, I'm going to need a bit of space for this one. And then let's have a go at a sketch. So we've got a circle. I think we're going to need to have an idea of sizes. So we can sketch this square. So let's have a look at the circle. The radius of the circle, well, pi r squared is 72 pi, so pi r squared is 72 pi, so the r squared is 72, and so the radius of that circle is square root of 72, which is 36. 70 is 36 times 2, so simplified gives us 6 root 2. So the radius of this circle is 6 root 2. Now the square had an area of 144, which is a 12 by 12 square. If it's passing through a midpoint of one of those sides, then it's at size 6. It's going to be across 6, which is less than 6 times root 2, because root 2 is 1.4-ish. So the square is going to overlap a bit like this, where this length is shorter than the radius of 6 root 2. So I might just add a couple of lines on there as well. So we've got our 6 root 2 there, and one sec, and our 6 root 2 here as well. Okay, so this is not the centre of the circle. If we're working out the area of the union of the two shapes, and we add together our circle 72 pi, our circle area, to the square area, then we have counted this. I'm going to highlight this section here in blue. We're going to count this area twice. This bit here, only the bit where the square goes over the circle. To that bit there. So let's have a look at how we can work out that bit, because that is the bit that's going to get subtracted from that total area of adding the two shapes together. The majority of it is part of the square. If I just add an extra little small square on there, then this triangular part of the blue is in fact an eighth of the square. So the blue bit is an eighth of the 144 plus that little segment between this chord. Let's have a new colour, between this chord here and this arc here. So this orange segment. So that first bit, that 144 over 8 is 18. So we've got 18 plus the segment. Oh, sorry, I've gone orange. So let's focus on this orange segment that we need to work out the area of. If you're working out areas, then you really need to know angles. So we need to know this angle here. We know that the radius is 6 root 2. If we need to know this angle, it'd probably be useful to know how long this line is from the smaller square's diagonal, and in fact that's how we're going to work it out. So we've got a 6 by 6 square, right angle there, and so that's the hypotenuse. So if we square it, add it, square root it, we get square root of 72 again. We've seen that before. So that's 6 root 2. So if this is a length of 6 root 2 across here, and this is a length of 6 root 2 here and here as well, then we have ourselves an equilateral triangle there. And if you've got an equilateral triangle, then you've got an angle of 60 degrees. So let's include that as well. So this is actually 60 degrees. So we need to know this little part here. The size, the area of the whole thing would be a sixth of the circle. So a sixth of the circle is 72 pi divided by 6, which is 12 pi. but we need to subtract. We only want this orange bit, so we need to get rid of that. We need to work out the area of the triangle. We could do base times height, and we could work out the height using Pythagoras, but I'm actually going to use half AB sine C. So it's 12 pi is the whole thing. So I need to do 12 pi minus the triangle, which is half AB sine C. So that was 6 root 2, half AB, another 6 root 2, sine C, so sine of 60, which is one of the numbers that we need to know, which is 12 pi minus, so we've got half times 6 root 2 times 6 root 2. Sine 60 is root 3 over 2. So let's tidy that up a little. These 2 root 2's make a 2, so it cancels there. The 6 divided by this 2 gives us 3 root 2. So we actually end up with that orange area. I'll make my pen orange just so we can keep track. That orange area, that little piece there between the chord and the arc, is 12 pi minus, and then we've got 3, is that right? 18 root 3. So that is what's going to be added on to the 18 for the area of the blue. So let's go for our final answer now. So we had the area of the full circle, 72 pi. The area of the full square, 144, minus the blue area, which is an eighth of the square, plus that little orange bit, which we just calculated to be 12 pi minus 18 root 3. So it is going to tidy up quite nicely. The 72 pi minus the 12 pi is going to be 60 pi. The 144, take away the 18, is going to be 126. And then take away negative 18 root 3. It's not quite the order that we were asked for there. So I have got C to be a number that can't be divided by a square number. So I've got the A is 60, the B is 18, the C is a 3, and the D is 126. So adding those together gives me 78, 81, 207. There you go, guys. Tricky one, that one. All right, guys, I wish you all the best for the next quest, and I'll see you again soon. Bye.